Good day, everyone. We are Group 3. Our discussion for today will be all about carboxylic acid and ester. But before we proceed to our discussion, we introduce to you all the reporters.
Aji, Erica, Justine, Shine, Kesaya, Destiny.
Alright, if you've been following the sequence on the previous lessons in naming alkanes, alkynes, alcohols, aldehydes, and ketones, next in line we will be doing carboxylic acids and esters. And then we will go direct in naming carboxylic acids and esters. What is carboxylic acid? Carboxylic acid is an organic compound that contains a carboxyl functional group. They occur widely in nature and are also synthetically manufactured by humans. These organic compounds are referred to by their trivial names, which contain the suffix "ic" together with acid. Example of this trivial name is acetic acid. The general formula of carboxylic acid is RCOOH. COOH refers to the carboxyl group and R refers to the rest of the molecule to which this group is attached. In this carboxyl group, there exists a carbon which shares a double bond with an oxygen atom and a single bond with a hydroxyl group. Here we have two pictures attached of the general structure of a carboxylic acid. On the second picture, you can see the carboxyl group or the COOH and R, which refers to the rest of the molecule into which this group is attached.
There are first four carboxylic acids derived from alkanes. These are methanoic acid, ethanoic acid, propanoic acid, and butanoic acid. Methanoic acid contains one carbon atom and its common name is formic acid. It can be found or used in insect stings. The ethanoic acid contains two carbon atoms and its common name is acetic acid. Its common location or use is vinegar. For the propanoic acid, it contains three carbon atoms and it's commonly known as propionic acid. You can find it or use it as a preservative for stored grains. Lastly, butanoic acid contains four carbon atoms and its common name is butyric acid. It is commonly located or used in rancid butter.
Carboxylic acid molecules are polar due to the presence of two electronegative oxygen atoms. They also participate in hydrogen bonding due to the presence of the carbonyl group and the hydroxyl group. These compounds have the ability to donate protons and are therefore rancid-Lowry acids. Carboxylic acids can be reduced to an alcohol by treating it with hydrogen to cause a hydrogenation reaction. Carboxylic acids are defined as weak acids, meaning that in a neutral aqueous solution, they do not fully dissociate to create H-positive quotients. So here we have a video in naming carboxylic acid.
In this video, we're going to focus on naming carboxylic acids. So, the basic functional group of a carboxylic acid looks like this. It has a carbonyl group and also a hydroxyl group. So this is your typical carboxylic acid. Sometimes you might see it written this way or even this way. So let's work on some examples. Let's begin. Let's start with this one. So here we have a 6-carbon carboxylic acid. So the first thing you want to do is you want to count the longest chain. So we have a total of 6 carbons. 6 carbons is associated with the name hexane, but instead of calling it hexane, it's going to be called hexanoic acid. Now, what if we have an alkene present? How will that affect the name of this particular compound? So once again, you want to count the longest chain, and you need to assign a carboxylic acid with a 1. You always want to start counted from the carboxylic acid. Now the alkene is between carbons 3 and 4. Now you want to pick the lower of the two numbers, which is 3. So this is going to be called 3, not pentane, but pentene, and then oic acid. Anytime you have a carboxylic acid, you need to add the suffix oic. Now what about this example? Let's say if we have a carboxylic acid that looks like that compared to one that looks like this. What's the name for these two carboxylic acids? In this case, you want to use the E and Z system. For the example on the left, the two groups with the highest priorities are the methyl and the carboxylic acid. Comparing the carboxylic acid versus hydrogen, the carboxylic acid functional group has way more priority than the hydrogen atom, and methyl has more priority than hydrogen on the left side. So whenever your two highest priorities are on opposite sides, you have the E isomer, and whenever they're on the same side, you have the Z isomer. So in this case, this is the Z isomer. But now, what is the name of each of these compounds? So let's count the longest chain. We have 4 carbons, and the alkene is on carbon 2. So this is going to be called E-2 butenoic acid. Now the other one is going to be the same thing, but the only difference, instead of E, it's now Z-2 butenoic acid. Now let's move on to our next example. Try this one. What is the name of this particular compound? So we need to start counting from the carboxylic acid. And which group has higher priority? The ketone or the carboxylic acid? Typically, the groups that are always at the end usually have more priority than the ones in the middle. So the carboxylic acid will be associated with the parent name. So how can we name a ketone as a substituent? This is going to be called 4-oxo, and after that, just the rest of the name, which is hexanoic acid, since we have a 6-carbon chain. So ketones and aldehydes have the name oxo whenever they're the substituent instead of the parent chain. Let's try another example like that. So this time we have a carboxylic acid and an aldehyde. Both groups are always at the end, but the carboxylic acid has more priority than the aldehyde. So the carboxylic acid will be associated with the parent chain of the molecule. NH2, the amine, as a substituent is called amino, and the ether, this is known as ethoxy as a substituent. So we need to start counting it from the carboxylic acid. So this is going to be called 4-amino. We need to put it in alphabetical order. Dash 7-ethoxy. Dash 8-oxo for the aldehyde, and then octanoic acid. Now what about this? What if we have a ring and a carboxylic acid? What is the name of this molecule? So we have 6 carbons in a ring, so it's a cyclohexane ring, plus a carboxylic acid. So this is simply called cyclohexane carboxylic acid. Now, what if there's some substituents attached to it? Let's say if we throw in a bromine atom and a methyl group. How can we name it? So automatically, this is going to be carbon 1. It's associated with the functional group that has the highest priority here. Now, we need to decide, should we count it counterclockwise or clockwise? Now, if we count it counterclockwise, we're going to have a substituent on 4 and 6. If we count it clockwise, the 2 substituents will be at 2 and 4, which is better. So that's the way we want to go. And then we just got to put it in alphabetical order. So B comes before M. This is going to be called 2-bromo dash 4-methyl. And then after that, cyclohexane carboxylic acid. Now, how about this one? What's the name of this particular carboxylic acid? So the carboxylic acid has more priority than the ketone and the alcohol. Now, H comes before O, so this is going to be 4-hydroxy and then dash 5-oxo. Since we have a 6-carbon chain, hexanoic acid. Now, what if we have a benzene ring with a carboxylic acid functional group? What's the name of it? So if you add benzene and oic, you're going to get benzoic acid. Now, what if we add an alcohol and an ether to it? How can we name it now? So in this case, we want to count it clockwise, so we can get the 2 substituents at 3, 4 instead of 4 and 5. And then just put it in alphabetical order. So H comes before M. This is going to be called 4-hydroxy dash 3-methoxy. And then benzoic acid. Notice that whenever you have an oxygen, you have the word oxy. Here you have a hydrogen attached to the oxygen, so it's hydroxy. And here you have a methyl attached to the oxygen, methoxy. I don't know if you caught that, but it's something useful to know. Now, what if we have 2 carboxylic acid functional groups in the same molecule? What do we do? So you need to use the word dioic since you have 2 carboxylic acids. But first, identify the longest chain. So it's 4 carbons. This is going to be butane. And instead of saying butanoic acid, it's butane dioic acid. So now that you understand how to name the last example, you can try this one. So we want to start counting from the side that's closest to the methyl and the ethyl groups. So the methyl could be on carbon 2 and the ethyl could be on carbon 3, as opposed to it being on 4 and 5. So the parent name is going to be associated with hexane. And then we have 2 carboxylic acids, so hexane, dioic acid. And now we need to talk about the substituents. E comes before M, so this is going to be called 3-ethyl dash 2, I put 4 for some reason, don't know why. So 3-ethyl dash 2 dash methyl, and then hexane dioic acid. So that is it for this video. Thanks for watching and have a great day.
Now, we proceed to ester.
What is ester?
Ester is an organic compound that reacts with water to produce alcohol, and it is derived from carboxylic acid. This organic chemical compound has at least one OH hydroxyl or carboxylic acid group and is replaced by an O alkoxy or alcohol group. Esterification is a chemical reaction wherein an alcohol and an acid form an ester as a reaction product. The name was derived from the parent alcohol and parent acid, but the simple esters are frequently called just by their names. The IUPAC was used to name esters, and it will be followed by the suffix OATE. It is characterized by a carbon bound to 3 other atoms. A single band was bound to a carbon, double band to an oxygen, single band to an oxygen, and a singly bound oxygen is bound to another carbon. The general formula of an ester is RCOOR with the apostrophe, where R and R with the apostrophe are both carbon-initiated chain or the alkyl groups, and the COO are the carboxylic acid. Here are some examples of its general structure.
Examples of esters include ethyl propanoate, propyl methanoate, propyl ethanoate, and methyl butanoate. Glycerides are fatty acid esters of glycerol. Ethyl acetate or ethyl ethanoate is an ester. The hydrogen on the carboxyl group of acetic acid is replaced with an ethyl group. The IUPAC names of esters come from the parent alcohol and acid. Many common esters are called by their trivial names. For example, ethanoate is commonly called acetate. Methanoate is formate. Propanoate is called propionate, and butanoate is called butyrate. Properties: esters are somewhat soluble in water because they can act as hydrogen band acceptors to form hydrogen bonds. However, they cannot act as hydrogen bond donors, so they don't self-associate. Esters are more volatile than comparably sized carboxylic acids, more polar than ethers, and less polar than alcohols. Esters tend to have a fruity fragrance. They may be distinguished from each other using gas chromatography because of their volatility.
Esters are chemical compounds derived by reacting an oxoacid with a hydroxyl compound such as an alcohol or phenol. Esters are obligose. Most naturally occurring fats and oils are the fatty acids, esters of glycerol. Esters with low molecular weight are commonly used in fragrance and found in essential oils and pheromones. Their flexibility and low polarity is manifested in their physical properties. They tend to be less rigid, lower melting point, and more volatile, lower boiling point than the corresponding amides.
So here we have a video in naming ester.
In this video, we're going to focus on naming esters. So here's our first example. Esters have 2 oxygens, and it contains 1 carbonyl group. That's the carbon double bonded to the oxygen. Now there's 2 parts that you want to focus on. The portion that has both oxygens, including the carbonyl group, and the other part. Notice on the right, we have 3 carbon atoms, 1, 2, 3. On the left, we have only 2. Now make sure you know the names of the first 10 carbons. For example, an alkane with 1 carbon is methane, 2 carbons ethane, 3 propane, 4 butane, 5 pentane, 6 hexane, 7 heptane, 8 octane, 9 nonane, 10 decane. Make sure you know that. So the 3 carbons on the right is going to be called ethyl with the end in YL. I mean, not ethyl, I take that back. Ethyl's 2 carbons. Propyl, since there's 3 carbons. Now, on the left, we have 2 carbons. Now, it won't be ethyl, but it's going to have the end in OH. So, it's called ethanoate. That's the portion on the left side. Now, when we put it together, the ethanoate should come at the end. So to name it, it's called propyl ethanoate. This is the IUPAC name. Or you can say propyl ethanoate. The common name for this is propyl acetate. If you want to convert the IUPAC name to a common name, there's some things you need to know. Whenever you see ethanoate, you can replace it with the common name acetate. Now, if you were to see, let's say, methanoate, you can replace it with the common name formate. And typically, if you see butanoate, the common name for that is, it doesn't really change much, but it's like butyrate. Now let's work on some more examples. So let's say if you have an ester that looks like this. What is the name for that ester? So feel free to pause the video, take a minute, and work on this example. See if you can come up with the name for this ester. So let's separate it into 2 portions. So on the right, this is 1, 2, 3, 4. This is the part that don't have the 2 oxygens. So that part, we're going to name it first. 4 is associated with butane, so we're going to replace ANE with the suffix YL. So this is going to be butyl. And on the left side, we have 3 carbon atoms. 1, 2, 3. 3 is associated with propane, but since that's going to be the parent name of the functional group, we're going to add the OA part. So it's going to be propanoate. Butyl propanoate. So that's how you name it. Here is another example for you. Try this one. What is the name for this particular ester? What is the IUPAC name and also the common name? So let's separate it into 2 parts. So this is the part that have both oxygens, and here is the other part. So the part that don't have both oxygens has 2 carbons, so we're going to name that first. 2 is associated with ethane, but we're going to add the suffix YL. And we're going to replace ANE with YL. So instead of saying ethane, we're going to say ethyl. And now for the portion on the left, the one that has the 2 oxygen atoms, we only have 1 carbon. So 1 carbon is associated with the name methane, but we're going to replace ANE with O8. So it's going to be methanoate. I guess we're really replacing just the E portion of the ANE part to be more accurate. Now, that's the IUPAC name, ethyl methanoate. What is the common name? Remember, we can replace methanoate with formate, so we can also call this ethyl formate. Go ahead and try this one. So once again, we're going to separate it into 2 parts. So on the right side, we have 2 carbons. So that's called ethyl. And on the left side, we still have 2 carbons. That's going to be ethanoate. That's the IUPAC name, ethyl ethanoate. The common name, we can replace ethanoate with acetate. So it's ethyl acetate. So let's separate into 2 parts. On the left, we have 5 carbon atoms, and on the right, we have 4. So what is the name of this particular ester? So the part that doesn't have the 2 oxygen atoms is on the left, and that's the part we want to name first. 5 is associated with pentane, but we're going to replace ane with YL. So this is going to be called pentyl. And on the right, we have 4 carbons, and that has the 2 oxygen atoms, so it's going to have the O8. So instead of saying butane, we're going to say butanoate. Now, if you want to write the common name from the IUPAC name, if you see butanoate, you can replace it with butyrate. So this is pentyl butyrate. Now, how about this one? Go ahead and name this particular ester. What do you think the answer is? So once again, we're going to separate into 2 parts. So this is the part without the 2 oxygens, and this is the part with the 2 oxygens. The left side is called phenol. Phenol is basically a benzene ring as a substituent. Benzo is a benzene ring with an extra carbon attached to it. So phenol contains 6 carbon atoms. Benzo, which is basically what we have here, contains 7 carbon atoms. It's the ring plus the carbon on the outside. So instead of saying benzo, we're gonna have to put the O8 part in it. So this is called phenol benzoate. And that's basically the name of this structure. Now what about this one? What do you think the name of this molecule will be? How can we name this particular ester? So here, this part has the 2 oxygen atoms, and this side does not. So let's start with the side that doesn't have the 2 oxygen atoms. We're going to name that first. So this part is the ethyl, and on the left we have a benzene ring plus an extra carbon, so that's the benzoate part. That's the parent name, which we need to write last. So it's going to be called ethyl benzoate. The OA part should always be written at the end, so make sure you do that. Now it's your turn. Go ahead and work on this example. Let's say we have a CH3 attached to a carbonyl group and attached to a benzene ring. So how can we name this particular example? So the benzene ring is the portion of the ester that doesn't have the 2 oxygens. The other part has the 2 oxygens. So this is going to be phenyl because it only has 6 carbons and not 7, so it's not benzyl. And the other one has 2 carbons, 1, 2. So instead of saying ethyl, we're going to say ethanoate. This time, the ethanoate goes at the end, as always, but phenyl comes in the beginning. So it's going to be phenyl ethanoate. So that is the IUPAC name. What's the common name for this? Well, since we have ethanoate, we can replace it with acetate. So the common name is phenyl acetate. Now let's work on some more complicated examples. Let's say if we have an ester with a complex substituent. How can we name it? So the portion of the ester that has both oxygen atoms is this part, and this one is by itself. So let's start naming the part that doesn't have the 2 oxygen atoms. So that's going to be called methyl. Now what about the part that has the 2 oxygen atoms? Now the first thing you want to do is identify the longest chain, starting from the carbonyl group. So we have 3 carbons, and the parent name is going to be, instead of propane, propanoate. Now notice that we have a substituent or a methyl group on carbon 2, and that methyl group is not associated with the left side but the right side. So it's associated or should be attached to the propanoate. So it's going to be 2-methyl propanoate. And we can write that together. Whenever you need to separate a number and a letter, use a hyphen. You don't need to separate 2 letters, by the way. So this is it, methyl 2-methyl propanoate. That's how you name it. So now let's work on another example. Try this one. So let's separate it into 2 parts. So the left side has the 2 oxygen atoms, and the right side does not. So we have 2 carbon atoms on the right side. On the left, the longest chain is 4 carbons. So let's start with the right side, the part that doesn't have the 2 oxygen atoms. So that's simply called ethyl. The longest chain for the part that has the 2 oxygen atoms has 4 carbons, so instead of saying butane, it's going to be butanoate. And we have a methyl on carbon 3. So we're going to say it's 3-methyl butanoate. So the whole name is ethyl 3-methyl butanoate. Now what about this one? How can we name this particular ester? So once again, let's separate it into 2 parts. This is the portion that has the 2 oxygens, and this is the part that doesn't have the 2 oxygens. So let's name the right side first. Since it's a complex substituent, we need to count the longest chain, which is 4 carbons. And we have to deal with this methyl group on carbon 3. Now, for a 4-carbon chain, instead of saying butane, it's going to be butyl. But we have a methyl on 3, so it's going to be 3-methyl butyl. On the left side, we only have 2 carbons. So that's going to be called ethanoate, or acetate if you want to write it that way. So this is the IUPAC name for that particular molecule. Let's try another example. Go ahead and work on this example. So on the left, we have a 3-carbon chain and a methyl on carbon 2. And it doesn't have the 2 oxygen atoms, so this is the first thing we're going to name. So it's 2-methyl, and there's 3 carbons in a parent chain, so that's going to be propyl. And now this is the parent name of the molecule, and there's only 1 carbon there, which is associated with methane. So that's going to be methanoate. So combined, this ester is called 2-methyl propyl methanoate. Try this one. Let's begin by separating it. So this is the part that has the 2 oxygens, and this is the part that doesn't have it. So let's start with the part that doesn't have it. As we can see, we only have 2 carbons, so that is going to be called ethyl. Now for the part that has it, there's 3 carbons. So we're going to have the name, instead of propane, propanoate. Now we have an OH group on carbon 2. What is an OH group called as a substituent, since the parent name is the ester? It's going to be called hydroxy. So it's 2-hydroxy propanoate. And of course with the ethyl in front. So the whole thing is ethyl 2-hydroxy propanoate. Try that one. Go ahead and name this particular molecule. So let's focus on the ester. The portion of the ester that has the 2 oxygens is the portion on the left side, and the right side just have 2 carbons, 1, 2. So we're going to name the part that doesn't have the two oxygens first. So once again, that's ethyl. Now for the part that has the two oxygens, let's count the longest chain. 1, 2, 3, 4, 5, 6, 7. Make sure you count it starting from the ester functional group. So 7 is associated with heptane, but we're going to use the word heptanoate. Now we have two substituents. We have a chloro group on carbon 4. And what is a ketone as a substituent? A ketone is called oxo, OXO, and that's on carbon 5, but we need to alphabetize it. C comes before O, so it's going to be 4 dash chloro dash 5 dash oxo heptanoate. And so that's how we can name this particular molecule. Here's another one for you. Try this one. Take a minute, pause the video, and work out this example. See what name you come up with, and then unpause the video when you're ready to see the answer. So let's go ahead and begin. Let's name the part of the molecule that doesn't have the two oxygen atoms, and that is the portion on the right side. The left side has the two oxygen atoms of the ester. So let's count the longest chain for the right side. It's 4 carbons, and we have a bromo group on carbon 2. So we're going to say it's 2 dash bromo, and instead of saying butane, it's going to be butyl for the 4 carbons. So we're done with the first part of the molecule. Now let's move on to the second part. So let's count the longest chain. 1, 2, 3, 4, 5. So we have an ester with 5 carbons. So 5 is pentane, but instead of saying pentane, we're going to say pentanoate. Now we have an amino group on carbon 4 and a methoxy group on carbon 3. So this is going to be 4 dash amino, and I'm running out of space, so it's going to be dash 3 dash methoxy, and then pentanoate. So it's 2 bromo butyl 4 dash amino dash 3 methoxy pentanoate. And hopefully I got everything there. I'm trying to be careful and avoid mistakes, because when you have a complicated molecule, it's very easy to make a mistake. So now this is going to be the last example for today. How can we name this particular ester? So because we have 2 ester functional groups, it's going to be a dioate. Now the part in the middle is the part that is associated with the esters. It has the 2 oxygen atoms. So let's count those carbons. 1, 2, 3, 4, 5. 5 is pentane. So the middle portion is called pentane dioate. And we have an ethyl on the right and an ethyl on the left. So we have 2 ethyl groups. So we could say it's diethyl pentane dioate. And I'm going to stop it here. So that is it for this video. Hopefully it's been useful to you and helping you to understand how to name esters and also some more complicated ester examples.